So this is actually, I think example 10 is a partial question. So you can see here, it is a little bit complicated. So remember, I told you from the beginning of our class, our ultimate goal is to find the value of u. Okay? In order for us to find the value of u, we have to find the value of h and t. So this is an example where you are actually combining everything that you have learned so far. Okay? So if you look at here, I'm just going to read the questions. Hopefully, you can understand the question and be able to solve the question. So example 10 is saying that oil is flowing through a 75 mm ID iron pipe at 1 meter per second. It is being heated by a steam outside the pipe, and the steam side heat transfer coefficient may be taken as 11 kilowatt per meter squared degree Celsius. At a particular point along the pipe, the oil is at 50 degrees Celsius. Its density is 880 kg per meter cube. It has a specific heat, and its specific heat is 2170 joule per kg degree Celsius. What is the overall heat transfer coefficient at this point based on the inside surface area? If the steam temperature is 120 degrees Celsius, what is the heat flux at this point based on the outside surface area? Okay, so you see here, given the equation for H, given 1 Cp is equal to 1 times 10 to the power of -3 kg per meter second, the thermal conductivity of the tube is 45 watt per meter degree Celsius, and the tube thickness is 0.0055 meter. So here you can see here, this is the combination of everything that we have been discussing so far. So I'm not going to solve this question for you, but I'm just going to tell you how everything is related to each other. Okay, so the question was telling you, you have a copper tube with an internal diameter. Okay, the diameter was I think 75, and then you have a oil flowing inside the tube. You have oil flowing inside the tube, and you have steam on the outside of the tube. So you have properties of oil, and you also have properties of steam. Now the question was asking you to find the value of U, I, and I think also find the value of dQo over dA. These are the two things the question asks you to find. Find the value of overall heat transfer coefficient based on the inside surface area, and also find the value of heat flux based on the outside surface area. So if you remember the equation for UI, okay, I don't actually remember the whole equation, but I think it is something like this: 1 over H4 dO over dI plus, I think, dMXW dI is dI over dL plus 1 over HI. Something like that. I'm not really sure because I also don't remember the equation. But in order for you to find the value of UI, so if you want to find the value of UI, you have to know all this. So I just write it here. In order for me to calculate the value of UI, based on the equation, I need to know the value of HO, I need to know the value of EI, I need to know the value of EO, I need to know the value of EL, I need to know the value of KM, XW, and also, that's it, right? HI. Okay. So in order for me to find all this value, I need to know, find the value of UI, I need to know the value of all these terms. So the first thing that you need to do is that you have to try to find which value is given and which value is not given. So the value of HO, you know that if it is HO, you are talking about heat transfer coefficient on the outside surface area. So if you look at the diagram here, you know that oil is flowing inside and steam is flowing outside. So I can automatically label that my heat I is going to be for my oil because I know that it is flowing on the inside, and my HO is going to be for my steam because I know steam is flowing on the outside. So based on that, I can actually determine whether I know the value of HO or HI. So remember, in the question, it has given you an equation for heat, but it did not mention whether it is HI or HO. It just gives the value of H is equal to something, something, something. Right? So it is your job to determine whether that equation can be used to find the value of HI or HO. So depending on whatever you are given in the question. And then you have to find the value of Pi. So Pi is going to be the internal diameter of the tube. DO is going to be the outside diameter of the tube. DL is just the log diameter. You know the equation. The equation will be here. DL, I think the equation is DL is equal to DO minus DI over ln DO over DI. This equation will be given to you. So you can find the value of DI. Km is the thermal conductivity of the material. So in this case, you have to find the Km of the copper tube. This is the value of Km. And then XW is the thickness of your tube. Okay? This is the thickness. So you have to find the value of XW. So once you have found all the value, it's just a matter of substituting all the values into the correct equation and then solving to find the value of. First part is to find the value of UI. The second part is to find the value of heat flux based on the outside surface area. So again, this is a kind of a hint for you guys. When you see that you have the term inside surface area, outside surface area, so definitely it is dealing with UO or UI. Okay? So you have to be able to understand the question and extract. So if you look at the question initially, it might be very, very difficult. But if you break down, you list down everything, you draw everything, then you know that you know what you have, what value you have, and what value you have to find. Okay? So please go back and try to solve this question. If you can solve this question, then I will have no worries for you guys to solve any question in your final exam. Okay, so actually you can see here, this is the combination of everything that we have learned until today. Because until today we have talked about heat transfer by conduction, which is related to the value of thermal conductivity. After that, we move on and we learn heat transfer by convection. So when we're talking about convection, we are talking about H value, which is our heat transfer coefficient or convective heat transfer coefficient. When we're talking about that, we learn about how to calculate the value for fluid flowing inside the tube or outside and across the tube. So basically, you have H for fluid flowing inside the tube and also H flow for fluid flowing across or outside the tube. So combine everything, the value of H, the value of HI, HO, and the value of Km, you get the value of UI. So this is our objective. From day one, we want to find the value of UI. That's why from day one, I told you K, H, and so we went on the steps on how to ultimately find the value of, and this U, the value of UI or UO, will be used in your second part with the where you design heat exchanging.